Hey friends, and welcome back to another adventure of Blink. Today's adventure is going to be maybe a little odd. It's a little different from the usual things that we've done together because I'm sort of doubling this as a product launch. It's something I've dreamed about and hinted at for a while. If you've been watching previous episodes, we've actually kind of been building up to it. There's a recurring theme through some of the recent builds. But it's becoming a real thing now, and I couldn't be happier to share it with you. So I'll start with a little storytelling to set the stage. I attend a church that records a video of the pastor's message each week and posts that to their YouTube channel. And so I've been dabbling a lot in social media, as you're well aware here, watching the adventures of Blink. But as I was browsing through their channel, I noticed that it takes them a really long time to get the video to 100 views. They have tons of followers, but we're just not seeing the traffic that we would necessarily expect to see. So, anyway, I started digging into why that might be. And what I found was that it came down to time. See, the staff have a lot going on, both professionally and personally. And as a result, they don't necessarily have the time that's required to market a YouTube video each week. There were some key points that I kind of noticed along the way. They don't have titles that attract attention. They're very good for cataloging, but there's nothing about it that makes me want to click the video. There's nothing clickbait, right? That might help nudge somebody to try it out and see what's in it. Most of the videos, they don't actually use the description field because it takes time to write. Somebody has to stop and think about it and create a paragraph that fits in there. But that means that the algorithm doesn't have any text to read to start understanding what's in the content and figure out how to push it out to the right audiences. There are no hashtags in use and that's kind of the same problem. But both of those together, the description and in particular the hashtags, are really critical for the YouTube algorithm to understand who needs to see this video, who I can put it in front of that might make them watch it. And then there's no additional marketing of the video at all. We don't make use of anything like shorts or other channels like Instagram Reels or TikTok to acquire new watchers and direct them back to the main content. And if you think about it, it makes perfect sense. All of these things take a lot of time to achieve. It's not something you can just kind of bang out in 15 minutes and you're ready to go. There's work involved in everything that I just said. So that was the problem that I was seeing. That was the thing that I wanted to go solve. I've got friends that are doing this work and they can't do it well enough to get it, out there consistently. But they don't have time to devote any more effort to it. And that seems like a great place for me to apply my recent learning about AI. So, given my recent adventures exploring AI capabilities, my brain was already kind of primed to solve this problem in this way. And so, what I did was build a social media assistant to help my pals using generative AI tools. What does that mean, Ben? What that was a whole lot of buzzwords in one sentence. I hate buzzwords, but it's really the only way to describe this. So maybe I can break it apart and talk about the plan. We're going to start from the finished video, the file that they would upload, and we're going to transcribe the audio out of it. We need to get the words of the speaker into text. Because that's what we need to feed into our language model. So we're going to take that transcript and we're going to create vector embeddings out of it. We're going to push those into a RAG application that uses a free large language model. In this case, Llama 3. I'm building off of the previous episode where we did the RAG sample app. But then we're going to have that app do several bits of work based on those bullets that we covered earlier. So I want to write a clickbaity title. I want to get a description summary. I want to find the appropriate hashtags that should be applied. And then there were some other things that popped up along the way. Wouldn't it be interesting to have a list of discussion questions that you could give to the audience that after they watch the video, here's some things you can go discuss with your family or a small group of folks, or maybe just personal reflection. So give them some questions based on the content that prompt them to ruminate on what they just heard. Uh, I thought it might be interesting to be able to write sort of a social media email invitation for next week's service. So, hey, I'm really glad you stopped by today. I'd love to see you next week at our services. But that template could be done in the voice, in the tone of the speaker. And then finally, like the crowning achievement for this, the hardest part of the process, so to speak, was finding quotable moments in the message and clip them out for use on short form platforms. So how do you make a TikTok out of a sermon? Well, you're going to have to find the statement that was made that's extremely quotable, that maybe is a hot take, that that would gather somebody's attention, that would capture them in that short form, where they go, oh gosh, as they're scrolling through their TikTok feed or whatever, they hit this and they're like, oh, wow, what did he say? That was really interesting. And it makes them tap to go find out more. So that seems like the hardest part, right? Because you're going to have to go back through the video and you're going to have to find these moments. So asking somebody to do that manually is really expensive. It takes a lot of time because it's like, well, now I have to watch the whole video over again to find those quotable moments. If I can get the robot to do it, then hey, we're good to go. There's no need for a person to have to rewatch this video to find all those things and then do all the video editing work to clip it out. So that's what I really wanted to automate. And then last, I'm going to drop all of those outputs into a folder after the app runs. So it starts up, it goes through this processing steps, and then it dumps out all of this stuff in a single folder for the staff to review. Blink, why didn't you just automate the whole upload? It's a good question, isn't it? I could totally make this a completely automatic process. I could make it so that somebody does this work and it spits out all the outputs and then it pushes them directly into the upload process and just takes care of it all. Robots can handle it all and nobody gets involved. But there's a couple of problems with that. The first one in my mind is sort of a trust issue. We've all seen the horror stories all over the news about large language models hallucinating, saying the wrong thing at the wrong time, not understanding the data properly. So we need to have a human in the loop. And that's important because we don't want to have that embarrassing faux pas where somebody pushed up a terrible thing to social media and they're like, look, that church said blah, 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 blah. And it was really a language model that got out of control. So there's always going to need a trust element where a human's in the loop to go, okay, I get what was output here, but we're not going to use that. It doesn't fit what we're hoping to portray. The other part of this is that I think any AI use without human interaction is unhealthy. Sure, I'm fully on board with making the work automatic, but a person should always govern its use. It's the safety thing like we talked about with the trust issue, but it's also kind of a philosophical stance to me. I don't like the idea of replacing people with AI. There's enough hype about that happening, like they're going to take all our jobs. We can't survive in a society where AI does all the work and we just sit around. What I really like to do is augment people's efforts with AI. And that's a slightly different frame if you think about it. No, I'm not looking to get you out of the way. I'm looking to enhance what you do so that you can be more effective with a little bit of tooling. So there's the general principle. There's how we're doing it. And now I'd like to introduce to you the PhilBott. It's sort of an inside joke. Our pastor's surname is PhilBott. And so in his honor, I decided to name my robot buddy after him. You can find the code for the PhilBott here on my GitHub. Stop by. I'll put a link up here in the video so that you can just click directly. I've made this open source on purpose because I have no intention of actually profiting from software in this case. I tend to be a little bit of a digital hippie, and I just want the information to be free, man. So stop by, check it out. I would love for you to play with it, see how it works. See how you can make modifications. Send me a PR. I'd love to make this into a dialogue between you and me. But over time, I'm expecting to continue to enhance. There are things that are a little bit raw around the edges because this is brand new software and I've not finished the full thing yet. But there is enough here that it's working and I can give this to people to try out. So we're at that phase of development where we're ready to start building the first release and package it up neatly. It's just not quite there yet. But I'd love to get your input, so please check it out. We'll go through a brief tour here today, but by all means, go dig in on your own. I know that if you're here watching me, you've got some passing interest at least in writing a little bit of code. So by all means, come write some code with me. So I think what I'd like to do next is to give you that brief tour for So I think what I'd like to do next is just give you that brief tour for the devs in the room. Let's take a look at the parts of the PhilBott. There are several components, and I've tried really hard to keep them coupled very loosely. I don't know where this is going to go in the future, and it's really important to me as a software practitioner that I don't tightly couple the different elements together. I want to keep it as loose as possible in case I have to rip one out and replace it. So let's talk about the general flow. Okay, so let's try drawing a diagram of what we're going to build. It might help you to understand a little bit better of what we expect to get out of this. So we're going to start with the idea of a raw video file. So there's some video that we've taken, somebody's speaking. That's how we're getting this all underway. But we can't use the video file by itself. So what we have to do is convert it to a WAV file. That's a really horrible sine wave, but that's what I was going for, is that this is your audio file. Maybe I need to draw another there. So you convert the video into an audio file because I only care about what was said. From there, I'm going to build a transcript. And this uses a library called VOSC, which the language models there are able to do text to or speech to text very simply. So I brought in the VOSC model to do the transcripting part. Now once I have a transcript, I'm going to pass that information, and along the way there's the process of creating vector embeddings. So I'm just going to write vector there. We turn the transcript into vectors, or into vector embeddings. I need to say the right words, don't I? But there, we're going to dump that information into a Chroma database. Now, Chroma, we're using as an in-memory database, so it's not actually storing anything to disk. It's just keeping it all in RAM, and it's only active for as long as the app is actually using it. But once the data is in there, then we have the ability to connect to a large language model. And there is the connectivity that we make. So the language model can then communicate back to the database because it needs the memory. It needs the information out of there in order to answer the questions. So what we do next is we have a Python program right here that knows how to ask the language model to do stuff. And we've built things like this before. So all we're doing now is making sure that everything on the back side of this, everything that I've already drawn over here, is now ready to give that data to the language model. And so our Python code is just going to output to a folder everything that we've asked it to do. Now, where did we ask it to do that? Well, I also built this in to use a YAML configuration file. So I'm going to put that over here just as a reference because that's really important. You see, out of the gate, if I give this to the people at my church, none of them are programmers. They're not going to know how to rewrite my Python program if they want to change the prompts that are being worked on. It's going to be hard for them to sift through all the code and deal with all that mess. It would be much better if they could just use a configuration file that's much easier to read. And YAML gives us exactly that. It's pretty much plain text. There's a little bit of formatting that you have to pay attention to make it work, but it makes it much easier for the average person who does not code on a regular basis to pick it up and make changes to it. So I've got that YAML file built out there as part of the program, and they can embed whatever they want. They can bring that in as a parameter, and it says here's the config I want you to use when you run this. So the running cycle of this ends up being, I don't know, maybe 5 minutes for a 30 to 45 minute message, but it gives them all of those things that we've talked about as outputs. So that folder then becomes just a thing they can take off and use to do whatever they need to do next. Okay, so now that we've seen the diagram, let's actually take a quick tour of the application. We'll look at all the detailed parts to satisfy your need to see code. Okay, so we're first going to look in the modules folder at transcriptor.py. This is a class that I made to wrap around the idea of building a transcript out of a video file. So my input to this class is going to be an MP4 or an MOV file, something that is a video that can be parsed by FFmpeg. So the first step in this process is actually to call an external program. In order to use the PhilBott, you have to have FFmpeg installed. And it's going to be used to extract the audio from the video file. So you can see that here in the get audio method. But let's see if I can go down here, because transcribe is really the flow of how the class works. The general gist is you instantiate the class, you pass it the file name of the input file, and then you call transcribe and it does all the work. So if you take a look, the first thing we do is get the audio. And we saw that method up here, which is FFmpeg, extracting it. It creates WAV files here in the same directory, which it'll then delete at the end of the method or later on in the method. So what you can see here is that we grab the audio segment from the file, and we're going to set the frame rate, which is a constant value that we pass in, and we're going to set the channels to 1. So what we're doing is pulling out the very first channel from the audio. It can be multi-channel audio, but if you pull the first channel, that's typically where you're going to have the voice that you want to listen to. It's sort of the default, I guess, but we're effectively making it into a mono output instead of a stereo output. And then we're going to export the audio into a separate file. So we have the initial FFmpeg extraction of audio as a multi-channel thing, and we dump that into the WAV file, like WAV file number 1 or whatever. And then we're going to extract that channel, that single channel, and make it mono by putting it into WAV file number 2. Then we're using something called the Caldi recognizer, which is part of the Vosk library. And this is going to be how we do transcripts. So the idea here is we now have an audio file, and there's a whole bunch of stuff being said in it, and we're using this as the way that we recognize the words in there and start to pull them out into transcript format. We set the words to true here. This is what allows us the ability to treat each word individually, and that's important because one of the things we're going to do as part of this transcription process is we're going to grab the timestamp where every word begins and ends. So we get an individual timestamp on both sides of the word, we can extract a single word from anywhere within the video file. We open the WAV file here, and we're ready to do some work. So if we see that the channels don't equal 1, or the sample width doesn't equal 2, or we don't have a none in get comp type, then we have to correct the inputs. So this means that we didn't transcribe, or we didn't convert the file format effectively out of the gate. And that's going to kill the program right there, so that we can correct our mistake. But assuming everything's good, then we have a print statement here just for debugging purposes, and we're going to dig right in. So while true, we go into an infinite loop that says I'm going to read 4,000 frames out of this audio recording. And if I have no data in it, then I'm done. I can move on. If I have data that I need to work with, then I'm going to ask the rec. So the rec was defined further up here. That's the Kaldey recognizer. Okay. And we're going to ask it to do the conversion, and that gives us data in a JSON file. And what's cool about this is it also includes all those timestamps. So we get back not only a JSON file containing each word as an element in the array, but each word comes along with all of its metrics. And we can choose which metrics. I haven't actually dug into what all's available in there, but there's a substantial amount of stuff. So after we've done that, we get the final result. And final result is effectively the full JSON file, which it's one giant text string of all the data. And we also pull it in as a JSON. I said that wrong. So you can do final result, which gives you the string back. And then you can do JSON.loads final result, which gives you the full JSON experience with all of the extra data. So once we have that, we can go through the results and start processing things to pull out the timestamps into tuples. And so we create our own array of tuples that consists of every word in the start and end. Those are the values we wanted. Now, like I said, there's other data that's available in there, but the tuples that we're going to use contain just the word. It's where it starts and where it ends. And that goes into an array that we can use later. After we've done all that, we close down our connection to the audio file, and we remove the audio files from the system. So we're cleaning up after ourselves as we go. We want to leave this in a state where it can just start up and run every time, regardless of where we are. Once we've got the transcript, we can, or we're now building the transcript, I should say, that we're joining all the elements in there with a space. So it goes through every word in the array and builds it into a text file. You'll notice that we don't punctuate anything in the transcript, and we don't capitalize anything in the transcript. It's literally just the words. So everything's one giant run-on sentence, so to speak. And then we've also got the timestamps that we're going to put into the class for easy retrieval. The reason I did this is because sometimes you have to pull multiple things out of the class, and you don't want to have to redo the transcribe every time. So I made class variables that capture all the results and store them for later. So get timestamps is just a method for outside things to call in and get the timestamps out of the class. So this find string timestamps is given a certain string, look for where that is in the overall transcript. This is really valuable for that quotable idea that we were talking about, because we're going to go look for whatever string they give us in the transcript, and wherever we find it, that's what we're going to use to get the timestamps. So I won't walk you through all the nitty-gritty details there. The short version is we go through a whole bunch of array stuff to find the words and figure out if it's a match. We'll move on down here to cut clip. This is the last method in this class, and its purpose is to take a start time and an end time and create a subset of the initial video file. So that video file is going to say, here's a string, and I want to start here and end there. And the output of cut clip is that I now have a new video file that only contains the items between those two elements. Pretty cool, huh? So the next element we'll look at, we'll close down the transcriptor here, is the RAG model app. So this is the thing on the other side of the diagram, the RAG application that takes in the data from the transcript, turns it into vector embeddings, stores it in a database, feeds that database to a language model, and then allows other things to be done against it. So let's take a look at what this class does. You can see I've got some constants here. I'm using llama 3 for everything. Because I'm running ollama, it runs on my local host at port 11434. And then the chunk size and chunk overlap, if you remember the previous video about RAG apps, those are settings that we use to divide up the content in the transcript. We don't want to pass the whole transcript in to be vector embedded as one unit. We want to carve out little tiny pieces so that we have little chunks of data and we can start to relate them to each other more closely. So those settings are all there. Shouldn't be any surprises if you saw the previous video. I will link to that previous video up here so that you've got that available to go back into the detail. Here's where we prepare the chain. So this is the first thing you call after you've instantiated the class. You're going to say, hey, give me the text splitter and then chunk out all the data based on those content, like the numbers that we picked above. And then we're going to do the embeddings. So embedded model, you can see the stuff right there for how to call for ollama embeddings. We're going to pass that data into a storage retriever that's created with Chroma. And then once we have the storage retriever created, we're going to combine that with the rest of the doc chain. Again, this is all very similar to what was in that previous video. And then I have an invoke method that says, given this certain command, run the command and return a response. So effectively all I did was take that RAG sample app from the previous episode and rework it into a Python class where I could make it call from somewhere else. And so where is that somewhere else? We'll go back to main and take a look. I'll put that aside for the moment, and let's take a look at our main class. This is the entry point to the PhilBott program. This is where all the high-level logic is stored. So you can see I've got a setup logging. I haven't actually used a lot of the logging yet. That's probably a personal failing. I need to go back and make it so that this logs effectively. I've got a method here to load a prompt file. So I'm actually storing the configuration file, the prompt file, as a YAML. If you're not familiar with YAML, I think it stands for yet another markup language. It looks like this. So I've got one object called prompts in my config.yaml, and inside there's an array of objects. Some of them are simple text, and some of them are video clip array. In fact, there's only one video clip array. But this is a configuration file that's now available for use within the program. It knows that it should find a type and an instructions and an output file name for each of the types of prompts. So if you configure your YAML using these settings, you can adjust this. You can have more things happen. You can have fewer things happen. And you can change the way each of them operates by changing the instructions in the given configuration. So that file gets loaded in through this method. We've also got a save transcript file, which is how we're taking whatever happened in the language model and pushing it out to a text file for storage. So the way this functions, remember the diagram, is that it takes in the data from the Chroma DB, and the language model is going to be invoked multiple times to do different things with it. And every response that the model gives us is going to be pushed to its own individual text file. This is nice because now I can give the user a folder full of all the things that were in the configuration, and they get this one package of quote unquote marketing materials that they can use to better market their video. So let's get into main and see how it works. We've got the the initialization for the logger stuff. I do have some basic logging out here, but I just haven't gone extensive with it yet. The short version is I'm pulling these in as command line arguments. So the way this functions, I should scroll down here to the bottom and let you see. I'm using a library which is called argparse. You can see it right up here at the top in my imports. And the idea behind argparse is that it's going to have these different arguments that I define that are attached to my command line. And so with the PhilBott, you can have a file argument, a config argument, and an output folder argument. So in my command line, I actually type it in this way. I would go python main.py, and I would do -- file, for instance, equals, and I would give it the source file. So you can see the help on that says it's the input video file that you're using. And then, so I would have a file there, right? And it would be like MP4 or whatever. And the next thing I would add is -- config. And the -- config tells me what the name of the YAML file is that I want to use. In this case, I only have config.yaml. So there it is. And then the very last thing is this output folder. And this is used because I don't necessarily know where I want my outputs to go. As the programmer, I want to send it wherever the customer, wherever my user decided they wanted to save it. So if they came in here and said, you know, put this in my home directory /documents/test, that's going to create a folder called test within the documents folder. And then that's what's going to populate with all of my outputs. Okay, I'm not actually going to run that right now. So we'll clear that out. Let's go back up to main and see what else is going on. So after we've pulled in the arguments, so if we have the file name that's given in the arguments, then we're going to go run that through the transcriptor. So remember, file is the input video that we're going to use. And so we call the transcriptor and we say, here's the file name for the video you should go use. That kicks off the transcriptor class, and then we just tell it to transcribe and give us the results back. And so that's what happens. The next thing we do is we check if there's an output folder. So the transcription here doesn't actually write anything out yet. It's just keeping it in memory. Like, we've done the work, we've gotten the transcript, it's sitting here ready to do something with. Output folder has to figure out whether we're going to, like, if it's been provided or not. So there's a default in this case. If you don't add the output folder parameter, it's just going to make a folder called outputs in whatever your current working directory is. And the same works for config. You can either provide the config like we were showing in the example, or config.yaml is what it's going to pick as the default for that. So if the output folder path does not exist, it's going to make the directory. That's how we handle it in Python. So if it's not there, we're going to make it exist, and then we're going to fill it with stuff. Then it's time to save the transcript. So remember, way back up here, we did t.transcribe and stored that in script. Now we're going to store script in transcript.txt. And that way, part of our output folder is the transcript. Now, the next thing we do is start to prepare the large language model for work. So we call the RAG model app, and we're going to pass it the script. So this is the transcript being passed into our RAG model app, and you saw how that works earlier. So when we get done with that, we're ready to prepare the chain, and then we can start using it. So we open up the config, and we say, go get the config file and load it in, and put that in a configuration variable here. So now we go through each prompt in the config. And the whole idea here is we already know what style of stuff should be in the YAML. So we're just going to look for those things. If it happens to be a simple text object, then we're going to save a transcript file where we create the output file that's mapped in that config. And then the last step of that, we're doing it all on one line here to make things succinct, but we do a rag.invoke and pass the instructions into the rag application in order to make it work. So that output is then directly dumped into the output file name that's associated with it in the config. So one line takes care of everything that happens in that. Video clip array is a little bit different because we have to have a few steps along the way to make this work. So the first thing is we have to make sure that the model has been instructed to handle this effectively. Video clip arrays have to be pipe delimited because what it's doing is it's looking for quotations in the original transcript. And when it finds them, it's storing them in a text string, but we need a way to be able to parse that so that we can tell Python what to do with it. Well, so what we ask for is pipe delimit the list of responses you get back. When you do that pipe delimiting, I now have something that I can key off of to say, hey, I know where each item is in that list. And so you can see we ask for a pipe delimited list of the direct transcript quotations only. Now this is really important because if you feed the data through the language model, it's going to naturally try to correct the spelling and grammar and punctuation. And we can't have that because we need to find that exact string in the transcript in order to get timestamps. So there's an explicit instruction: do not format or add notes or alter the original text in any way. All we want is just give us the quotable spot out of the original transcript. So now I know what the words were and I have an exact string that I should be able to search in my transcript and find and bring back. So we save that out because we want to document what's happening there. So you actually get an output file that contains your quotables at the same time that you get the actual video files. So once we've pulled in the data, you can see that, where did Y come from? I forgot. Just a second here. Oh, Y is set right there. So I take the response from the rag up here and I split it on the pipe delimiting. So that gives me things that I can go look for. I can iterate through Y to find each individual quote, and then I can take the information and pass that back into find string timestamps. So you remember seeing that method over in the transcriptor, that we now have the ability to say, I want to find this string somewhere in the transcript, and I want you to give me the beginning and ending timestamps of the first and last words in that case. Now, if I can't find them for whatever reason, because the model didn't follow my directions well or something like that, I just skip over it. And that's what you see here with the else condition on this. But the then condition says, I've now gotten this string and I found it in my transcript and I've gotten back timestamps. So if I got all that to work successfully, then the next thing I do is cut a clip, and then I'm going to save that in my output folder. So you can see here it's renaming the file, and then we do the cut clip and we say here's the output file name, and that's what actually takes the TikTok clip, so to speak. I think the way that I've configured this right now is 25-second blocks. So I said I want my TikTok to always be 25 seconds. And the string that it usually finds is much shorter than that, like 8 or 9. But I wanted to be able to provide just a little context around it in case there's something that was taken out of context, and I want to make sure that people have a chance to adjust it and still make it usable. We like hot takes, but we want to make sure they're within the bounds of being able to show the context. So after all of that has happened, we output we log that the script finished successfully, and you should have a folder that looks something like one of these. So I've got several examples over here of things that I've run. And so this is how it actually outputs into my folder. It creates the discussion questions. That's one of the things that's in my config file. It creates the hashtags. It creates the invitation. Here's the quotables.txt. This is what gives us the list of items that are important to our quotables. And these are the strings I want to go find. And then each of the quotations becomes an MP4 of its own. So if I were to open one of these up, I won't bother doing it in the video, but if I were to open it up, what you would actually see is a 25-second clip around one of those quotable sections. I've got my summary, I've got my title, and here's the original transcript. And you can see, like I said, there's no punctuation. I mean, it'll do apostrophes like in contraction words and things like that, but there's no periods, there's no capital letters, there's no anything to separate that out. It's just a wall of text. So that's what we're operating from. That's why we had to do all that extra instruction to the model to make sure that it knows you can only respond with exactly the text that was in the transcript. And that's how the PhilBott works. So our next step is to start imagining ways to use this that are completely different from anything that's already been imagined. That configuration file means that you have the option to change whatever behaviors. If you want to come up with something new to ask the model to do, you go add it to the YAML and it's ready to roll. That would be my next question to you. What would you do with this? How would you alter it to make it useful in your world? So friends, that's another adventure of Blink. And I hope you've enjoyed this experience of seeing a product launch, an idea that came from nowhere. It came from playing around with weird technology things and trying to learn a little bit about AI. And it's now become something that I can share with people who can actually use it to make their lives easier. They can offload mental capacity to the models so that they don't have to do that work. And in this case, it actually augments their abilities because it's stuff that they weren't doing before, but now they have the capability to do instantaneously with no individual physical effort. That excites me so much that I'm able to make a difference in somebody's life by writing a little bit of code. That's what gets me out of bed every morning. And I hope it's something that appeals to you too. I'd like to think that that's why we're in this field. That's why we do what we do as technologists, is to make the lives better of people around us. So I hope you've enjoyed the experience. I hope you've had fun learning a little bit about how to do artificial intelligence in a practical way. I will make sure that this program is in my GitHub. It's available open source. I would love for you to participate. Try it out. Drop me an issue if you find something that's not working right. Put a feature request in, or if you're so inclined, I would love to have collaborators. I would love to continue to build the capabilities of the PhilBott into something that's more valuable to more people. So I'm signing off for now. I hope you've had a good time. I can't wait to see what kind of things you build based on what you've learned today. We'll see you next time.